Welcome to a new episode of the Power Talk, the official podcast powered by ROHM Semiconductor Europe. My name is Katrin Hases-Schmidt and I'm working as a content marketing manager for our company. My guest today is my colleague Michael Maurer, Senior Application Marketing Manager ADAS. Some of you might already know him, as he was my very first podcast guest when we talked about ROHM's hidden champion solutions in ADAS a couple of months ago. Welcome back, Michael, and a happy new year. I hope you had a pleasant break to reload batteries for new exciting projects coming up this year.
Hello, Katrin. First, Happy New Year 2021 to you and your family. Good to see you again after the Christmas break. Many thanks in inviting me for an additional session with you.
Today, we are talking about another interesting topic, a technology called QuiCurrent. That's a new development for DC-DC regulators applied in the automotive industry. And to provide our listeners with a short preview, this technology will also be one of our focus topics during the upcoming Embedded World Fair in March. Michael, could you please first of all provide us with a short introduction and describe this technology for us in a nutshell?
Yes, Katrin. Here a very condensed summary. QuiCur is a technology for switching DC-DC regulators, which reduces the output capacitor values and therefore contributes to system cost reductions.
Before we jump to the development's technical details, which design challenges of DC-DC regulators are existing in the automotive industry, and which parameters should therefore be considered in advance to tackle these issues?
Very important question, Katrin. For switching regulators, the typical main parameters to be considered are the conversion efficiency, DC setpoint accuracy, AC ripple and transient load responses with its overshoots and drop voltages. Beneath the technical parameters, solution costs will play an important role. Here, it is not just the cost of the regulator, it is also the PCB area and the bill of material. Since the electrification is continuously increasing and the application complexity is rising, the number of DC-DC regulators is growing. So every component which could be economized will play a role in reducing the overall solution cost. Indeed, products like capacitors, which are in the price range of cents or subcents, will contribute to the cost, as it is not just the cost of the component, it is the PCB area, the design, the assembly, the inspection, and the test of such components, which contributes to the cost. Furthermore, due to the high volume of requested components in the market, it can become very challenging in sourcing the suitable components at the requested time to the manufacturing facilities.
So how does ROHM's so-called QuiCur technology solve this issue? How does it provide added value to product developers? Could you please outline some of the QuiCurrent key features here for us?
After spotting the cost and sourcing problem, especially for the capacitors, our engineering team was researching on solutions how to reduce the output capacitance on switching regulators with no impact on electrical performance preferably. While reducing the output capacitance, the transient load response of a buck regulator is badly influenced, means we can notice higher voltage overshoot and undershoots when the load changes. Now we are touching one of the fundamental switching regulator problems, the error amplifier dilemma. Low output capacitance requests fast error amplifiers, means amplifiers with high gain. On the other hand, high amplification reduces the phase margin. High phase margins are requested to ensure stable operation of the switching regulators. So you can see the dilemma. Our chips designers found an innovative solution overcoming this dilemma while splitting the feedback loop into a slow, high accuracy path for stability and high DC accuracy and a high speed path for fast transient load responses and lowest voltage drops and overshoots. The technology is trademarked and named as QuiCur from QuiCurrent. Our designers furthermore added the possibility to select the loop gain via an external pin, so that the output capacitance can be optimized based on the maximum allowed drop and overshoot voltage.
Truly interesting. To make this product more tangible, could you perhaps also share with us some concrete examples describing in which applications our QuiCur solutions can be applied?
Technology and product usage is always key. So we considered the first technology implementation for an automotive secondary buck family, means switching regulators with an input voltage of up to 5.5 volt and reasonable output current of 3 and 4 amp. Due to our experience, such class of buck regulators addressing smaller SoCs or applications with higher power consumptions are perfect candidates for such new technology, as it would help to reduce the overall cost and the requested PCB area. These two buck regulators will operate at a switching frequency of 2.2 MHz to offer small inductor values, include all typical IOs, and will come in a small 3 by 3 mm QFN package. Regulator typical features like overcurrent, short circuit, and overvoltage protection, as well as self-protection thermal shutdown, are built in.
Impressing. Seems like QuiCur can be applied in various applications. In this connection, could you perhaps already provide us with a status quo regarding the product development at this point?
Our designers and application engineers are currently evaluating the first silicon, and the results are very promising. Transient load responses with half of the output capacitance will result in 20% lower, means better droop voltage at comparable products. The output capacitance can be furthermore reduced to 1/4 of the original value, and the voltage drop will only be increased by 10 millivolt at typical load changes.
And when will the products be market ready?
The first product we are currently aiming for is the BD9S402, a switching regulator with 4 amp continuous output current capability. First engineering samples will be available soon, in February, and the mass production is planned for summer, August this year. Engineering samples for the 3 amp version are planned to be available in June, and the mass production is expected for the beginning of the next year.
Sounds promising. Thank you very much for this newsworthy talk and being my guest today, Michael.
Many thanks, Katrin. Nice talking to you. I hope it was interesting information I could provide to you. Always a pleasure being invited by the Marcom team. Hope seeing you soon with some new, upcoming and interesting topics.